As creative programmers and artists, we need to be able to manipulate our sounds, either to create interesting musical effects or just for getting multiple sounds to gel together in a mix. One of the most powerful tools that we have at our disposal is the filter. Simply put, filters open up an entire world of sound shaping and sound coloring. And they allow us to create really essential bread and butter musical tools like tone controls and equalizers. It's how we can take a straightforward drum loop like this one and transform it into something much more sonically interesting like this. It's also how we can take a normal sounding voice and transform it to sound like it's coming from a telephone. Well, for achieving all these type of sounds, filters are the answer, and the Web Audio API's got 8 different flavors of filters. So in this video, you're going to get started filtering with JavaScript and the Web Audio API. Let's get going. First things first, we create our audio context on line 1 and assign it to const ctx. Now for our sound source, we'll be creating a basic oscillator using the createOscillator method. And we'll want to connect this oscillator to context.destination or ctx.destination. Next thing to do is to set the oscillator type to be sawtooth. And the reason for this is that we want to start off with a sound source that's rich in harmonics or overtone content. And the sawtooth waveform provides that for us. But what's the reason for starting with something rich in harmonics? Well, check it out. The first filter type we're going to use, remember now I said there are 8 different types. The first type is called a low-pass filter. And what it does is it attenuates or reduces the high-frequency content. Hence the name low pass, right? Low pass. By attenuating the high frequencies, we only allow certain low frequencies to pass through. So we want to start with a nice harmonically rich sound source which we can manipulate. Now, I opened up an equalizer here in Logic Pro X just to help us visualize what the low-pass filter is doing. Listen here to this buzzy synth pad and notice what happens when I reduce the high frequencies. You can hear the sound becoming darker and more muffled. The frequency we set the low pass at is called the cutoff frequency, and only frequencies below this cutoff are allowed to pass through. So let's go back to our code and set up a low-pass filter. With the Web Audio API, the audio node for creating a filter is called the Biquad filter, and the method we use is called createBiquad filter. So we can say const filter equals ctx.createBiquad filter. And then we'll rewire the oscillator to first go into the filter and then have the filter connect to ctx.destination. Now, the default cutoff frequency for the Biquad filter node is 350 Hz, and the default filter type is low pass. So you can already hear that the buzzy sawtooth wave from before has become a lot darker sounding. Now let's try some different frequency values and see how the waveform's tonal color changes. The low-pass filter is probably actually the most popular and widely used filter type. Have you ever heard the term subtractive synthesis? Well, this is an analog synthesizer concept where we start with more harmonically rich content, using waveforms like sawtooths and squares, for example, and then subtract or filter away the parts of the sound that we don't want. And this really helps to shape these basic waveforms, giving us so many more sonic colors to work with. The counterpart to the low-pass filter is the high-pass filter. The high-pass filter does the opposite of the low-pass filter. It filters out the lower frequencies, those below a set cutoff, and only allows the higher frequencies to pass through. So check this one out as well in Logic Pro X. And listen to how the sound becomes thinner and thinner the higher that the cutoff frequency is set. Just like with the low-pass filter, the high-pass filter can be used as an effect, or to shape the sound to achieve a certain tone, perhaps something brighter or thinner, for example. But another really common usage of the high-pass filter is simply as a utility tool, to remove things like extraneous, unwanted rumble, or subsonic frequencies that might not be apparent to the ear. If we clean up or remove these frequencies with a high-pass filter, then we can do away with these frequencies, which tend to eat up so much valuable headroom in our mix. So let's go back to the code now. We can change the filter type to high-pass by writing filter.type equals high-pass. And then we can experiment with some different cutoff frequencies to hear the effect. Now, I want to introduce a very important filter concept here, and that is Q. Q is short for quality factor, but what you should really be thinking about in terms of Q when it comes to the low-pass and high-pass filter types is resonance. When we increase the Q with these filter types, we're increasing the frequency right around the cutoff frequency. And in doing so, a resonance or a peak is created. Now, the usefulness of this is that it can further color and enhance the sound, and it can also often help to bring the sound out in a mix. So let's go back to Logic Pro X once again, and we'll try experimenting with some Q values. First with the low-pass filter, and then with the high-pass filter. The last filter type we'll look at in this video is the Bandpass Filter. And this one allows only frequencies in a specified range or band to pass through. So really, if you were to take the low-pass filter and put it in series with the high-pass filter, you would achieve essentially a bandpass filter. You see here in Logic that if we engage the low-pass and high-pass filter simultaneously, what we're left with is the band of frequencies which are allowed to pass through. So let's go back and set this up in code now. As you might expect, we'll need to set the filter.type to be bandpass. And then in this case, frequency.value is going to be the center of the frequency range which we want to allow it to pass through. But even though we know the center of the frequency range that we want to pass through, how would we know how wide this frequency range should be? Well, with the bandpass filter, the Q value works a bit differently than the low pass and the high pass. The Q value, in this case, controls how wide the frequency band should be. The higher we set the Q value, the more narrow the frequency range will be, and vice versa, a lower Q value will give a wider band of frequencies. So, in this video, we explored the Biquad filter node, and we learned some basic concepts around filters. We talked about why they're so useful and how to get started using them with the Web Audio API. Now, in particular, we looked at three types: the low pass, the high pass, and the band pass. And we talked about how the low pass filter is so widely used and how it's really fundamental to the whole concept of subtractive synthesis. The two important audio params that we looked at are the cutoff frequency and the Q, and we saw how these can be used to shape the sound and to produce resonance. So if you feel like you got something out of this video, please give it a like and consider subscribing to the channel. In the next video, we'll go even further with filters, and we'll examine the other filter types which the Web Audio API has to offer. See you there.